Hello everyone. So this lesson's on sine and cosine ratios. It's actually a lesson that follows a lesson on tan ratio. And we'll start off by recalling that any of these trigonometric ratios, today being sine and cosine though, will always only apply to 90-degree triangles. So sine and cosine ratio are using the 90-degree triangle. You have a reference angle theta, and opposite theta, you would have the opposite side, the adjacent side just beside it, and the long side of a 90-degree triangle is called the hypotenuse. If you're referencing from the angle up here, again, if theta is over here, opposite that, it's like saying opposite and kind of like a goalie who's opposing him. The goalie would be over here. There's opposite now. Okay, the hypotenuse is the long side. That never changes. And just beside the angle of reference, theta is adjacent. So that side that's beside the angle, same as over here, that side that's beside the angle, they are adjacents. Okay, we define sine as the following. So the sine of theta is the opposite, so I'll write op, stands for opposite, over hypotenuse. I'll just write hip. And we remember that thanks to SOHCAHTOA, our memory aid for trigonometric ratios. So that's so. The sine of theta, S, so that S there, is the op divided by hypotenuse. So op over top of hypotenuse. Cosine is similar. The cosine of theta, though, takes the adjacent and divides it by the hypotenuse. So it's that ratio we're interested in. So if we wanted the cosine of this angle, we would have to take this adjacent side and divide it by the hypotenuse. And remember that thanks to SOHCAHTOA. For cos, it's ka. Let's look at some examples. So example 1, find the variables, and I look at this 90-degree triangle, and I see the unknowns x. Now, anytime you have a 90-degree triangle, the tools at hand are Pythagorean theorem or trigonometric ratios. And Pythagorean theorem will not work here because you would need at least 2 known sides. We only have the 9 known, we don't know this side, and of course we want to find this side. So that's how you know you need trigonometric ratios, and as soon as you know that, I like to write out SOHCAHTOA. And I'm going to use that to help me remember the formulas and to help me decide which trigonometric ratio I'm going to use. Will I use sine, cos, or tan? So have a look at your diagram. The reference angle is known, it's 25 degrees. Opposite that is the unknown side x, so we write O for opposite. The adjacent has no information, and the hypotenuse is 9. Remember, the hypotenuse is that long side, and it's always across the 90-degree angle. So for this specific example, we know the hypotenuse, so let's go find that in SOHCAHTOA. I underline it. And we want to find the opposite, which is an unknown x. So let's look for O, opposite. And as soon as you have 2, there's your trigonometric ratio you're going to work with, sine. And thanks to SOHCAHTOA memory aid, we know how to write the sine formula. The sine is the opposite divided by the hypotenuse. So let's do that. Sine, well, what, of 25 degrees is opposite over hypotenuse. Sine of 25 degrees. My opposite's unknown, it's x. My hypotenuse is 9. Remember the quick cross multiplication technique we talked about, where all I really need to do is multiply 9 into sine 25. Okay, because there's like, this is a fraction over 1, and well, 1 times x is just x. So x equals 9 sine 25 degrees. That means x equals 9 times sine 25 degrees. And we realize using our calculator that it's the following. So you can do this all in one shot. You could go 9 times sine 25 degrees, and you end up getting 3.8. So x is 3.8, and that's all this asks for. So you're done that question. Okay, going into example 1b, we have another 90-degree triangle. We've only been given one side. We can't use Pythagorean theorem. Pythagorean theorem needs you to have two sides known to find the third. You're going to need trigonometric ratios. This being a sine and cosine lesson, you're expecting it to be one of those two. To help you decide, I write SOHCAHTOA. And now I have a look at my diagram. The reference angle is 65 degrees. Across from that reference angle, or opposite it, would be this side. And we know nothing about that side. Okay, so the long side is always hypotenuse, and it's opposite the 90-degree angle. And just beside the angle of 65 is the adjacent. Okay, and our triangle here for B, we're definitely going to have to go after the hypotenuse. So I'm going to look at SOHCAHTOA for an H, for hypotenuse. It's found in sine and cos. And now I'm going to look through SOHCAHTOA for an A. And it turns out I want to use the cosine. And I remember the cosine is the adjacent divided by hypotenuse, or this little memory aid, ka, where A is on top of H. And it's time to do the math. So here we go. I'm going to do it a bit quicker this time. Cosine 65 degrees. Okay, I know it's the adjacent over the hypotenuse. So 9.4 over x. I'm going to cross multiply x into cos 65, and I'm going to get x cos 65 degrees. There's like a 1 here, and it multiplies 9.4. Okay, and now to isolate x, see x is multiplying cos 65 degrees. I have to divide cos 65 degrees out. And you have to be fair to the equation. You got to do it on this side too. Okay, and you end up canceling these two cos 65s. X remains isolated. You can do this in one shot with your calculator. Check it twice if you have to, but you can go 9.4 divide by cos 65. And you end up getting 22.2. You can say units. It's not really an application, so just 22.2 is fine, but we'll leave it like that. Alright, so did you look carefully at this question? Because this question has two unknowns. We found the unknown side x, and now we need the unknown angle y. You ready to try a trig ratio for that? I'm not. Here's why. All triangles add to 180. If you have a known 90-degree angle and a known 65-degree angle, it's pretty easy to get y. Y is always going to be the leftover from 180, take away 90. Just write it down here. Take away 65 degrees. Y is going to equal 25 degrees. Okay, so you fully solved the question based on what they asked for. Moving on, for example C, I'd like you to try it. I will quickly set you up. You want to find the unknown angle x, and you have to go through labeling. So opposite x, it's like two goalies facing each other. looking at each other, they are opposite, so 7's opposite. And we happen to know the hypotenuse is 16. So let's stop there. Now you know we'd usually write SOHCAHTOA out, but look, you have opposite, and you're going to need to find x using hypotenuse because that's the only piece of info you have. So as you look through SOHCAHTOA, which one uses O and H? This one. So you're going to need a sine. Sine of x, and it's op over h. And I'll let you fill in the rest. Pause the video and come back, check your answer. Okay, so you're back. Hopefully you did the work and you got an angle of 26 degrees. Here's the solution, and we'll move on. As always, bring questions to class and we can clarify things there. So example D is our first instance of a double triangle. These are actually two 90-degree triangles, and we're going to cover that in class. Feel free to try it if you want, and let's talk in class when we see each other. Next up, we'll do question 2, or example 2 here. And don't worry about the book reference. It's from an old textbook. For question 2, we've got this 90-degree triangle, and we're given a hypotenuse here of 20 centimeters and this angle of 41 degrees. So I want to show you how to do this one without having to really write out SOHCAHTOA, but more like have it as a reference and look at the triangle and sort of choose the right trigonometric ratio quicker. So you've given this triangle, you know you can't use Pythagorean theorem. You're going to reference off 41 degrees. Okay? Another thing I need to tell you is we're out to find this side x. If you're out to find that side x, you want to get to a point where you can look at this and you can say, well, that's opposite, and the long side's hypotenuse. And you kind of want to stop there and say, well, if I need opposite and hypotenuse with this reference angle, that's O and H. And in the 3 options for trigonometric ratios, O and H is sine. So you don't have to go through and do the underlining like we did earlier. You can just sort of know SOHCAHTOA, know it's got O and H in sine, and jump right into it. So we need sine 41 degrees, and we want to put the opposite over the hypotenuse. So we're going to do that right away. Our opposite is x, and our hypotenuse is 20 centimeters. And you're immediately going to multiply 20 into sine 41 degrees, sort of like our cross multiplication shortcut. And it would look like this. X equals 20. You don't even have to write times. It's 20. Right beside it, sine 41 degrees. So this means 20 times sine 41 degrees. You want to grab your calculator, and you want to do this essentially in one shot. So 20 times sine 41, you end up getting 13.1. And again, if you're in application, look for units. It's a length, it's centimeters. Okay. Don't worry about the story that goes with this, but normally you'd have a concluding sentence. The length is 13.1 centimeters. So bring your questions to class. There's some practice work to do, and we'll take up question D from above, and others too, to go further with this idea. See you soon.